as we look at life on this earth, and we look at all the living factors that come into play for the plants, for the animals, even things within the atmosphere, and we look at everything on this earth that creates life. We realize, first of all, okay, that matter cannot be created or destroyed. Okay, matter cannot be created or destroyed. Well, if it can't be created or destroyed, then what does it do? Well, if it can't be created or destroyed, it just changes forms. Okay, so what happens is, and later on when we look at the chemical aspects of this, we'll look at where the carbons are and the hydrogens and the oxygens. But what we have to realize is that the day that the earth was created and formed, there was the same amount of everything. Nothing, no new matter on earth. No new water, no new carbon, no new hydrogen, no new oxygen. Everything, there's the same amount as the day that the earth was formed. So here we go. So it's like, well, you're like, well, no, it rains, there's water coming down. So what we do is we have to take a look at the rotation and how this water changes form. So we're going to look at three different areas. We're going to look at the water cycle, we're going to look at the oxygen carbon dioxide cycle, and we're going to look at the carbon cycle. So we're going to look at those three. So when we look at the water cycle, and you may have had some of these before, you may not. It's pretty important, so we put it in every single biology book that you've ever had. You've studied probably some of the water cycle just because it's so important, and we got to understand that. So the water cycle itself, we can start anywhere on here, but let's start up in the clouds. Okay, what are clouds? Clouds are condensation. Okay, clouds are condensation. So what is condensation? Condensation is gas to a liquid. Okay, condensation is gas to a liquid. Okay, so that's what happens if you're in the bathroom and you're taking a shower and you have a really hot shower going on and all that steam is coming out. What's happening? Well, the steam is a gas. It's actually water vapor. Okay, and so that water vapor may form on your mirror, and eventually we get enough condensation, we get enough of this gas that begins to turn to a liquid. We start seeing the drops come down. Okay, we call that condensation, when it goes from a gas to a liquid. All right. So where's the gas to begin with? Okay, so we have water vapor. As a matter of fact, our atmosphere is made up of 1% of water vapor. Now, what does that mean? Well, we can measure humidity and relative humidity of how much moisture is in the air. Okay, how much moisture is in the air. So if it says 100% humidity, does that mean we're in the bottom of the ocean? No, it means that the water vapor capacity in the air is at 100, which might mean that it's about 0.02%. So if we say it's 100% humidity, it means the chances are it's probably raining, because that means that the water vapor we can't handle any more of the water gas in the air, that it's got to turn to a liquid, because we've got to get rid of it because it can only hold so much. Okay, so the water vapor is in the atmosphere and in the air. Okay, it forms the clouds. What are the clouds? The clouds are condensation. It's where the water vapor is beginning to turn into droplets of water. Okay, so then as it rains, snows, sleets, hails, whatever it does, that's called precipitation. Okay, so precipitation is the liquid. Precipitation is the falling to the earth. Okay, precipitation is falling to the earth. I don't want to just say liquid, but it could be hail. Okay, so it could be a hailstorm. What exactly causes hail? It's kind of interesting. What causes hail is we have this condensation high up in the atmosphere, and as it's going through cold area, it freezes the water, and then it goes through warmer area and it thaws the outside of it, and then it goes through cooler area and it freezes. Yeah, as a matter of fact, the atmosphere, you would think that the closer you get to the sun, the hotter it would be, but that's not the case. We actually went to Africa to work with teachers. It was really cool. Another story for another day. But we were flying up in the air for about, we flew for about 12 hours to London and then about 14 hours on to Nairobi. And what happened was we were flying at 35,000 feet, and so you could follow the airplane had a deal with how high you were flying and also the temperature. And so the temperature was like negative 70 degrees up there, 70 degrees below zero at 30,000 feet. Wow. So we think that it's really hotter close to the sun, but that's not the case. The sun is giving all this heat off, but it's not giving it off in radiant heat, it's giving it off in ultraviolet heat, wavelengths. Wow. Well, that's, once again, a little bit of another story for another day. But as the Earth absorbs these ultraviolet light, okay, the Earth heats up and then it gives off heat. Okay. So that's what's happening. That's why it's warmer on the surface of the Earth, is because the Earth is giving off this heat, and there's a lot of clouds. It actually holds the heat in. So a really warm night happens a lot of times when there's no clouds in the day, and we can warm up the ground, and then the clouds form, and it won't let the heat back out into the atmosphere. So once again, it's kind of interesting. As we go through hot and cold, we could get hail, we could get sleet, we get rain, but that's precipitation. So it looks like the moisture, we're making moisture, but we're really not. We had water vapor in the air, and we'll talk about how it gets up there. So as the water comes down and hits the ground, okay, some of it is absorbed by the ground, and some of it is in the form of runoff. Some of it is absorbed by plants, okay? Some of it's absorbed by plants. The runoff goes into rivers and lakes, some of it eventually to the ocean, okay? But regardless of where that is, whenever we have water in runoff, whether we have rivers, lakes, oceans, then the sun comes, heats up the water, and then we have another phase change, which is change from solid, liquid, or gas. Okay, we have evaporation, and evaporation is from a liquid to a gas. So we have evaporation occurring. Okay, that can even be in a water puddle. It can even be. It can be if you have a little kid's swimming pool in your backyard. Wherever you have a surface of water, you can have evaporation. So what is that? You have the liquid water. Okay. And it goes to a gas. You can literally put liquid water on your desk, and eventually it turns into evaporation, goes up into the air. So what does it do? It goes up and it makes what? Water vapor, gas in the air. So we continually cycle this through. Cycle meaning a continuous circle or continuous path. Okay. So what happens to the water that goes into the ground? Well, we have groundwater. Now, that groundwater is kind of interesting because we even have underground aquifers that store water, and we even have underground rivers, okay? And so this underground river could actually even take the water to the ocean or to a river or to a lake, or it may stay in the ground in pockets of water. So that's why in a lot of areas, especially in New Mexico, where we don't have a lot of rain, okay, we'll go down with a well and we'll find this groundwater down here, okay, and we'll pump that water out, okay, and use it for our house, okay. So a lot of times we'll go down and we'll pump out the groundwater. All right, so once again, what are we doing as we do this? Okay, we're continuing recycling the water. Now, let's look at this tree. Okay, trees and plants. You've got grass along here. You've got whatever growing grass, bush, whatever. But as the water goes into the tree or the grass or the plant, and it goes into the leaves and goes through the process of photosynthesis. Okay, then it gives off the plant through the process of photosynthesis. Gives off oxygen, but it also gives off water vapor. Okay. Now this process, okay, this process of the leaves giving off water vapor is called transpiration. Okay. So transpiration, is also a liquid to a gas. Okay, liquid to a gas. And so what happens to that gas? Well, it becomes water vapor. And here we go. We're taking the transpiration. We're adding to the water vapor in the air, the water cycle. We've got evaporation. It's adding to the water vapor. And so when the sky gets so much water, and it's kind of interesting because we have winds that blow. Okay, so we talk about clouds building up. So whenever an area whenever an area has more water vapor than it can hold, then we begin to get rain, okay? So what's happening when the lightning hits? What's happening when the lightning hits? That's called nitrogen fixation. So here's all this water vapor up in the air. Now, I want to go one step closer, okay? I want to go one step closer to more than what you've had in terms of just maybe textbook water cycle. Let's look at a water molecule. Okay, let's look at a water molecule. So a water molecule, H2O, okay, is made up of an oxygen and a hydrogen and a hydrogen. Okay. Now here's why nothing can exist without water. Water. We have to have water to live. Water does a lot of things. Well, here's what happens. Okay, here's what happens. We have one oxygen molecule, which is pretty big, and two hydrogen, or one let's call it an atom. One oxygen atom and two hydrogen atoms. But what happens is anytime we see something that's bent like this, okay, as opposed to this is called linear. We'll get this in chemistry, and this is called bent. Okay, so this molecule is bent, and this is linear, straight line and bent. So anytime we have a bent molecule, we know that the charges on this water molecule, one is a plus charge and one is a minus charge. Oh, okay, well that's kind of interesting. We know if it's a linear charges because like charges, okay, repel each other and unlike charges attract. So if this is a plus and this is a plus, then the two plus charges would repel each other and make them go away from each other. Okay, so that's important. So now we know that like charges repel. Okay, and unlike charges attract. So this is kind of a deal, and I won't expand on this a lot, but with the water molecule, what happens is, since it's bent, we have a positive and a negative. Well, what kinds of things is a positive going to pick up? A positive is going to pick up all the negative things. What's the negative going to pick up? All the positive, because opposites attract. Okay? So all of the positive charges are going to pick up all the negative things, and all the negatives are going to pick up all the positives. So look at this water. This water is doing what? It's the same thing as when you wash dishes in your sink. Okay? You take all this water and you put the soap in there, and the soap helps give everything a charge. Give things a plus charge or a minus charge. So what happens is, when you put the water on there, all the dirt, all the grease, all the spaghetti sauce, all the all the butter, everything that was in there, okay, is attracted. If it's a positive charge, it's attracted to the negative. If it's a negative charge, it's attracted to positive. So what happens with water? Water is called the universal solvent. It will dissolve anything. But what does it do? It stores it right here. It stores it, okay? So it traps it in this water molecule. Well, the reason I mention that, and I want to close with this, is what's the problem with the water cycle is some of our water, even though we don't have any new water, right? Okay? Well, some of our water is getting polluted. What if this water molecule has oil in it? Okay? If it has oil in it, then the water molecule is sewed up. It can't be used anymore. When it has oil in it, it no longer evaporates. It no longer goes into transpiration. It can be absorbed into groundwater. It can be in the ocean, but it can't turn back into vapor because the oil doesn't vaporize. Oh. So if we have grease in the water, or we have gas in the water, or we have oil in the water, we have anything that can't vaporize, then the water is frozen and it's sealed out of the water cycle. So environmentally, that's why we're so concerned about our water. Okay? So we're going to stop there with the water cycle, and we'll pick up with the oxygen carbon dioxide cycle.